Hello, my name's Mr. Tinkler. I've been teaching in South Wales for roughly 20 years. And if you've seen my previous 8 or 9 videos, you'll see this is all linked to additional maths. It's a great qualification. It's a good introduction to A-level maths. I've been teaching it since 2013, I think, and use it with my classes. I've done it variety over lunch times to actually teaching it fully when I finished the higher tier GCSE maths qualification. And this is one called equation of tangents. It will back up something you've done in higher tier maths, but it's more of an A-level topic. Some of my previous 9 videos have been sort of linked to higher tier maths, well additional. This is more of an A-level, and you'll see this quite early on when you do A-level next year. So, to create an equation, and again, the language I use, the wording I use will be slightly different to what you're used to in your centre, but it's pretty much the same wherever you are. To create an equation, you need 2 things. The gradient, which is normally known as dy dx, and a coordinate. Then you're going to use this following formula. Now, different schools or centres might teach you that in a different way. They might teach you y minus y1 equals m open brackets x minus x1. That was the way I was taught in school. The reason why I use it in this format is because I know, and most of my year 11 classes will know, that gradient is changing y over changing x. And that's the reason why I write in that form. There's nothing wrong with using y minus y1 equals m open brackets x minus x1. I've taught that way. I sometimes have a problem with it. If m is a fraction, I find it easier writing this as a fraction, but you'll get used to that over time, and whichever way you're pushed into that direction in the future. Okay. Now remember, from higher tier maths and also from additional maths, tangents touch the curve, T for touch and T for tangent. And obviously we need to know an equation of a straight line at a curve, and that would vary on depending where on the curve you are. So that's why I'm saying you need to know the gradient, because this will tell you the gradient anywhere, but at a particular point on the curve, it would affect what the gradient is actually worth. Most of the questions, although not my first one, but most of the questions give you an x coordinate for a very cheap, easy mark on additional maths. And it's often the case on AS maths as well. You have to find the y coordinate. So this first question is different to the rest. I think it's from the 2012 or 2013 paper, one of the early papers. So you've got to find the x coordinate of the point on the curve where the gradient. Well, the key word being here, gradient. Because when I'm looking at gradient, we need to think about dy dx. And because of when you see the word gradient, you'll often see the letter m is for gradient. Well, that's using when it's on a straight line. Generally, m is used for when we're looking at linear equations, y equals 3x plus 7, 2x minus 5, for instance. This one is a quadratic, it's a curve. So that's where we generally look for the gradient, and we rename it as dy dx. So, all in one go in this one. First of all, I've differentiated. That's in my first set of videos. So do not try this video until you've done any differentiation. I'm sure in school you won't be taught that. So find the x coordinate where the gradient of the tangent is 15. So I've differentiated this bit. Differential of 2x, don't forget the differential of 5x is 5. If you know that linear, the gradient of minus 5x is minus 5 anyway. And then I've replaced the dy dx with the 15. 15 equals 2x minus 5. Add 5 to both sides, 20 equals 2x divided by 2. However you're showing your centre, x equals 10. It's quite a straightforward, which is probably why it's only worth 2 marks. My next slide's more of the general questions have been since the more recent years. So my next one, 6 marks. There's obviously quite a bit of work to do. Find the equation of the tangent to the curve, y equals 2x squared minus 8x at the point where x equals 3. Give your answer in the form x plus by plus c equals 0. Now, in additional maths, this is really important. Generally, from my experience, A level, they don't mind, or further maths, or A2 maths, they don't mind which order it's in. But for additional, it needs to be in this format, as you'll see in one of mine later. Okay, you'll notice x equals 3, but it doesn't talk anything about y. And as I said, for an equation, you need the gradient and the points. Now, I can't remember what I've done next. Some years I will find out what y is straight away, and some years I'll do differentiation. On this one, I decided to find out the y value straight away. As I say, it's a very cheap mark. 3 squared is 9, 2 9s are 18, minus 24. It's minus 6. That's a very cheap mark for what's considered higher further maths for year 11s. Now, next thing I need to know the gradient. I need a gradient and a point. I only had half the point, so now I've got the full point. The gradient, I do dy dx. I'm happy with quite my layout. I've written dy dx equals 12 minus 8 equals 4. I really should have written the line below dy dx equals 4. That will do for the day. And this is when you get used to the idea of m equals y minus y1 over x minus x1. Or, as I say, in your schools, you might well do y minus y1 equals mx minus x1. So on my next slide, just put it all together. And I've got y minus y1 over x minus x1. So if you bring the x minus x1 up there, you would end up with m over brackets x minus x1, which is another way of teaching the same thing. So I've gone for y minus minus 6. Be careful, because that minus 6 over there. Y minus minus 6. And I've gone over x minus 3. Got these coordinates from here. Then I multiply up, or multiply both sides by x minus 3 to get rid of the fraction. Don't forget, you've got to multiply out everything in there. So that's why I multiplied out the brackets. And as it says in the question, needs to be in the format ax plus by plus c equals 0. Now, I wouldn't worry the fact it says minus. Okay, often you'll find them say minus. I've never seen a question, and I won't ever say a question when it says in the format ax minus by plus c or minus c. It's always going to say in this format ax plus by plus c. So it doesn't matter these are minus numbers, and it doesn't matter that there's not a 1 in front of the y. Okay, that's just rearranging. I've taken y from both sides, and I've taken away 6 from both sides. That's the first question. You might want to go through that one before looking at the next question. So they are fairly samey most years. The next question looks very similar. In fact, the level of differentiation is actually easier because it only says 3x squared plus 6. Now, for 6 marks, I like this topic. Can't tell you what it'll be. It was question 13. They're normally at the second hand of the paper, but they'll be where they are. And in additional maths papers, there's no order. It's not like higher tier where the C grade work goes first. So, first of all, at the point where x equals 3, as I say, we haven't got the coordinates. So hopefully I've gone and substitute 3 into there. You can use a calculator to calculate paper, but I generally do this in my head. Remember, bid mass, bod mass, you do the square in first. 3 squared is 9, times 3 is 27, plus 6 is 33. So that's my first very straightforward, cheap, easy mark. Next thing, hopefully I've done the gradient. dy dx, because I need the gradient and a point. If you're in my school, it's written on my board permanently, but also it's important that I might not remember it, so I regularly use that as my starter. What do we need to find an equation? And that will be used in a couple of topics in additional, but it'll be used a lot in A-level. So when dy dx equals 6x, remember the differential multiplied by the power decreases by 1. Differential of 6 is 0 because the line y equals 6 is a straight line and a straight horizontal line has a gradient of 0. So when x equals 3, 6 is 18. Some years I might call that MT for gradient of tangent. When you do in AS maths, you will do something called the equation of the normal as well. So I will often change my labeling, but dy dx to gradient is that. Next thing. I now use the formula, m equals y minus y1 over x minus x1. This one's a little bit simpler because both these coordinates are positive. So 18 equals y minus 33 over x minus 3. Same thing. Next thing, then I'm going to multiply both sides by x minus 3. And again, it's got to be in the format. Now, this question doesn't actually say it. Most of the questions do say in the format ax plus by plus c equals 0. So hopefully I got into the routine of doing that. Very similar question. Next one. Again, 6 marks, x equals 4, no y coordinate in this format. Say A level, you don't have to be in that format, but in year 11, additional maths, I would probably leave it in that format because most years I'm used to seeing it like that. So in case I make a slip and forget about it, I try and write in that format. So same thing again. Substitute 4 into the equations gives us an answer of 0, which could be interesting. In fact, it makes life a lot easier, to be honest. Next thing I'll then do is work out the gradient. And the gradient, dy dx, multiplied by the power, 2 5s are 10, take one off the power, so that's why it just says 10x. Differential of 20x is just 20. Okay, it's minus 20x, it's minus 20. Substitute x equals 4 in there. 10 fours are 40, minus 20 is 20. Next thing, set the equation. Make sure you get the x and y coordinates the right way around. So m equals y minus y1 over x minus x1. There's x1, and there's y1. Multiply both sides by x minus 4. 20 lots of x minus 4 equals y. 20 lots of x minus 80 equals y. And I've rearranged it. Interestingly, all the questions so far I've had a minus y, I believe, in the middle. 20x minus y minus 80 equals 0. Don't forget the equals 0. Now, if I was you, I'd probably stop the video and look through this one and have a try yourself. The original equation got something slightly different on it, but nothing majorly. 6x squared minus 18x plus 13. So far, we've only had an x term or just a plain term. This one, we've got an x term and a plain term. Okay, at the point where x equals 2. So first of all, I'm going to find out my y coordinate by substituting that in. I write down my steps. You don't actually have to, but I always think it's worthwhile writing down my steps so I know exactly what I've done. You can certainly just straight away substitute 2 into the equation and of the quadratic, and then you can substitute 2 and it'll give you the answer 1, and by more means you can write down 2. But I think it's worthwhile you understanding where it's come from. Okay, that's the equation of the quadratic, and we're doing the equation of the tangent. Tangents are always straight lines, which is why they don't have squares in them, why they're just y's and x's, not y squared or x squared. Okay, so as I said, differential is slightly different on this one. 6 2s are 12, take away 1 off the power. 18x, take 1 off the power. 18 1s are 18, take away 1 off the power is 0. X to the power of 0 is worth 1, so that's why it's 18. And a differential of 13 is 13 is a horizontal line, so the grey horizontal line is nothing. That's why it disappears. I don't write plus nothing. Some people might tell you to do that. Next thing, substitute x equals 2 in. The dy dx, this gives us the answer of 6. Again, I think if I did this again, I would have written my solution dy dx equals 6. I'm not a big fan of having 2 equals on the same sides. Not very good for OCW questions in GCSE maths. Then I've written 6y minus 1. Looks like I made a mistake originally. Looks like I mixed up the x's and the y values. But obviously, I've corrected it before I scan these solutions in. 6 lots of y minus 1 over x minus 2. Multiply both sides by x minus 2. Leaving you the answer be yet again 6x minus y minus 11. Why are they always going to be minus y? Well, they're not always going to be minus y, but because we've just got y here, there's always going to be just a y there. We don't have 3y, we don't have 2y, and generally those questions will end up in that format. Now, I'm just looking to see if I can see anything different about this question. Express your answer in the form y equals mx plus c. So that is a different format. I'd be ashamed to lose a mark when all it's to do with you just rearranging. So make sure you highlight that, underline that when you do this type of question. Again, just reading the question, find the equation of the tangent. Tangent's a straight line at the point where x equals 2. Only x equals 2, nothing about y. So x equals 2. I've substituted 2 in here. 2 squared is 4. 20 plus 7 is 27. 227. Next thing, I've differentiated. Differential of 7 is 0, so that's why that's disappeared. When x equals 2, dy dx equals 20. Straightforward there. And I've gone for 20 equals y minus y1. Some people might well take you to write y1 and x1 up above these two to help. Multiply both sides by x minus 2. And you'll end up with the line 20x minus y minus 13 equals 0. Now, I actually wrote the wrong answer. And why did I write the wrong answer? Because probably I was so used to getting them in a format ax plus by minus c, or ax plus by plus c equals 0, that I didn't read the question properly. So I've subsequently added on. It's got to be in that format. Now, that's a format most of you might well have been taught it in school anyway, y equals mx plus c is a term that lots of people know. So please make sure you read this bit here before moving on to the next question. Okay, that's the end of another video. And hopefully you found them useful. I'll say there are 9 other videos in this link, so there's 10 videos so far, and that's the majority of the course covered. I hope you find them helpful, and I hope you enjoy your additional maths. It's a great qualification, and so is A-level maths. Good luck all.